Hello, this is Dr. Joyce Miller, and I'm going to go over the pre-lab questions for Lab Activity 7.1. This pre-lab is due at 4:30 p.m. on October 10th. So we're going to talk about building the Lewis structures for different compounds. So we're going to do some of what the lab has us to do as a pre-lab. So it tells us to review the sections in your textbook on Lewis structures, resonance, and formal charge, and then draw the 2D Lewis structure for each species in the appropriate table on the data sheet, pages 207 to 12. Record the total number of valence electrons that the molecule has where it's indicated in the table. Make sure to minimize the formal charge on all atoms and include resonance when appropriate. So formal charge basically has us have the number of electrons on an element or an atom be very close to the number of the group. So we're going to look at what we need to do, and then we're going to do the parts it says. There will be more parts that we're not going to include, but we'll do that in lab. So let's do the pre-lab. So first of all, it says to indicate the number of electrons, the total number of valence electrons that the molecule has. So we're going to use the periodic table to find out the number of electrons each element has or each atom has. So the group 1, they have 1 electron in their valence shell. Group 2 has 2 electrons in their valence shell. Group 3 has 3. Group 4 has 4. Group 5 has 5. Group 6 has 6. Group 7 has 7. And Group 8 has 8. So we're going to use the periodic table. We don't need to worry about the transition metals at this time because none of the problems in the pre-lab has us address that. So let's begin. I'm going to just use a blank piece of paper to do the first one, and you can put it in your table. So here we go. Page 207 in your lab manual has you first do carbon tetrachloride. So the things we're doing for the pre-lab for question 1 is to find the valence electrons, the number. So number of valence electrons, and then draw a Lewis structure, keeping in mind the formal charge and resonance, if there is any. So we go to the periodic table and we see carbon is in group 4, so we have 1 carbon, so times 4 equals 4. Now chloride is in group 7, and there are 4 of them, so 4 times 7 equals 28, giving us a total of 32 electrons in the valence shell of this molecule. So now we're going to distribute those, but we first of all have to draw the skeleton for the Lewis structure. So in order to draw a Lewis structure, we need to know which element is going to be the central atom. So this is where we can use that information from the previous lab when we look at electronegativity. So the more electronegative something is, the less it wants to share electrons. So it will be on the outside of the outer part of the molecule, not the central atom. So something that's less electronegative will be the central atom. So fluorine is the king of electronegativity. Everything else can be compared to fluorine. So anything we go away from fluorine as we go the same row, things are going to have less electronegativity. So for instance, oxygen is going to have less electronegativity than fluorine. Nitrogen is going to have less electronegativity than oxygen. Carbon less than nitrogen. Boron less than carbon. So we can just use that general rule for drawing the Lewis structures. Also, because fluorine is king of the whole periodic table when it comes to electronegativity, anything below fluorine is less electronegative. So chlorine is less electronegative than fluorine, but it's more electronegative than sulfur. So as you go this way, electronegativity decreases, and as you go down, it decreases. So if you remember that fluorine is king of electronegativity, then that will help you solve the Lewis structures as far as which atom goes in the middle. So we have carbon and we have chlorine. So carbon is further away from fluorine, so I'm going to put it in the middle. Also, nature likes symmetry. So carbon in the middle, and then we're going to put chlorines around it, and we have 4 chlorines. So now we have our skeleton built, but we don't have our electrons built. So we can indicate electrons with a little circle, or a pair of electrons like that, or we can draw a pair of electrons like this that's bonding electrons, and so that counts as 2 electrons when we draw a line like that. So 2 electrons would be shared in a bond, in a covalent bond. So carbon likes to share electrons, will gladly share, whereas chlorine likes to hog them. So we're going to draw 2 electrons here, 2 here, 2 here, and 2 here. So now the chlorine wants a bunch of electrons, and 8 is the happy number. Happy number. So chlorine wants 8 electrons. It will share some, but likes to hog them and not share. It's just an electron hog because it's so close to fluorine, which is the biggest hog of all. So we're going to put 8 electrons around chlorine. Well, we already have 2 that it's sharing, but we're going to put 2 here that it's not sharing. So unshared pairs there, and here, and around this chlorine, because all the chlorines are equally electronegative, so it's not going to want to share. One chlorine is not going to want to share more than another chlorine. That's just not how it works in nature. So now I have 8 electrons around everything, but I need to check, do I have 32 electrons, because I need to have 32. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32. So this is the number of valence electrons. Solve for the first one for number 1, and then this is the Lewis structure. Now, of course, in the lab, you'll be answering more questions about this. So we have satisfied all the atoms in here, and chlorine, who doesn't like to share, is not sharing, and carbon, who loves to share, is sharing. 8 electrons, so everybody's got 8 electrons. Carbon's is sharing 2, 4, 6, 8. So it has 8 around it too, but it's willing to share. I'm making them have human emotions, but you understand. It's all got to do with energy and the pull that protons have for the electrons. So I like to put it in simple words, but you can think of it more sophisticated if you want to. But carbon is further away from fluorine than chlorine, so that's why it's going to share more than the chlorine. So now let's go to the next one, methylene chloride. And how many electrons does carbon have? Well, once again, we go to the periodic table. It's in group 4. So 1 times 4 equals 4. Then we have hydrogen. We have 2 of them, and it's in group 1. So 2 times 1 equals 2. I'm sorry, 2 times, yeah, there are 2 of them, and each one has 1, so we have 2. And then chlorine, we have 2 chlorines, and we have 7 in each chlorine because it's in group 7. You can always go back to the periodic table and see that. So we have 14. So we have a total of 14 plus 6, so we have 20 electrons. So now let's put somebody in the middle. So even though hydrogen is further to the left than carbon, we can't put hydrogen in the middle because hydrogen can have only 2 electrons to share. Everybody else, well, almost everybody, is happy with 8. But hydrogen can't have 8. It's only got 1 proton, and it just can't pull 8 electrons towards it. So it has to be on the outside. It can never be a central atom. Poor hydrogen can never be a central atom, even though it's on the furthest left of the periodic table as we have it here. Sometimes you'll see it over here on top of helium, but this particular periodic table has it on the far left. So we have 20 electrons, and we're going to put that carbon in the middle again. So now it's going to share 2 electrons. Oh, I'm getting ahead of myself. We're going to put hydrogen on the outside, and we're going to put 1 here, and we're going to put a chlorine here and a chlorine here. So now we have our skeleton. We have 1 carbon, 2 hydrogens, and 2 chlorines. So we're going to distribute those 20 electrons. We're going to satisfy the carbon first, the central atom. It just happens to be carbon this time, but you want to satisfy the central atom first. So 2, 4, 6. Hydrogen can't have any more. That's all they get. So we have 6, it's 2, 4, 6, 8. And so now we have 2 more that aren't being shared. 2 more there, 2 more here, 2 here, 2 here, and 2 here. Okay, so now we have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So now we have our skeleton and our 20 electrons distributed. So that's the first 2. So let's look at phosphorus, trifluoride. So phosphorus is in group 5. So it has 5 electrons. There's 1 of them, so 1 times 5. And then fluorine has 3 of them, and of course it's in group 7, so 3 times 7. So we have 5, and we have 21, so we have 26. So you know already who goes in the middle and who goes on the outside, and you know how to satisfy the phosphorus. But let's see if that works. So we're going to put phosphorus in the middle, and we're going to put the 3 fluorines around it. So let's go 2, 4, 6. Now we don't have another one to put up here, so let's just kind of hold that off for a minute. And so with 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. And now we can make phosphorus happy with 2 on there. So we have 26. So we could have done it the other way. We could have satisfied phosphorus because it's in the middle. We could have given it 2, 4, 6, 8, and then distributed the others around it. That would have been perfectly okay to do it that way, to satisfy the central atom first. And you can see the fluorines have more unshared pairs than the phosphorus, because phosphorus is to the left and down from fluorine, so it's not going to hog the electrons like fluorine does. Okay, so now going on to the next page. Let's see here. Formaldehyde. Formaldehyde. So carbon, one carbon times 4, 2 hydrogens times 1, and 1 oxygen times, it's in group 6. Group 6. So we have 4, 2, 6. So we have 12 electrons. And now we're going to put carbon in the middle, and we're going to put the hydrogens around it and oxygen. So here we have 2, 4, 6, 8, 10, 12. And here, in order to satisfy oxygen, we'd have to put another one there, but we don't have enough electrons. We only have 12. So when we don't have enough electrons, what do? We double bond. So we got to satisfy the oxygen, we got to satisfy the hydrogens, the carbons. The hydrogens are already satisfied with 2. So we're going to put a double bond there. So now it's probably better to draw it like this. Those electrons don't want to be close to each other. And there's 2 there. So 2, 4, 6, 8, 10, 12. So we had to double bond because we didn't have enough electrons to satisfy everybody. So I think you can continue that method. Oh, one thing I want to point out, you have some ions to do. So let's look at nitrogen is in group 5. So we're skipping ahead to page 210. Nitrogen is in group 5 and oxygen is in group 6. So 1 times 5 for the nitrogen is 5. 2 times 6 is 12 for the oxygen. However, we have a negative charge. So we have another electron. So we have plus another 1 electron because there's a minus 1 charge. So remember, minus charge stands for electron. They're negatively charged. So this adds up to 18 electrons. So when you have an ion, if it's positively charged, you got to take away electrons depending on the charge, and if it's negatively charged, you got to add electrons depending on how big the charge is. So just to tell you about that one. And sometimes you have down in here, These will, they can have more than, like sulfur can have more than 8 electrons to share. So you might have extra electrons. If you have extra electrons, probably put them on the central atom because they're sharing so many, and if you can have a spare or unshared pair, it'll take them, the central atom, especially when it's down in groups or periods below period 2. So I think we'll stop there for question 1. So where are we here? Okay, let's stop. And then we'll go to question 2 in the next video.